Hey there. So I'm going to continue on with capillarity. So hopefully you watched the other two videos when I did a little demonstration with what I call the rainbow walker. And today we're going to do more definitions and more examples of capillarity so you have a better understanding of this concept. So capillarity is also known as capillary action. So due to my poor handwriting, I'll read it because you probably can't read it or it's hard to see on video. So capillarity is the ability for water to move upwards when it's forced into tight spaces. Now what I have here is this little demonstration, and we did this for the science fair numerous times. Mr. Mossy helped me out for different experiments. So let's say you wanted to water plants, but obviously we have a vacation or a long weekend or distance learning. So how do you water the plants over an extended period of time when you can't be there? Well, you can use capillary action to do it. So my great drawing here is, this is a plant. So there's 4 of them.
I thought it was a birthday cake.
And this, it does look like a birthday cake. These are 4 different plants. Hold on. That's my wife, everybody. Say hi.
Hi.
She sounds like a little kid, I know. So, here's 4 different plants. And now you know that the plants, since they're green. And this is a tray over a tub or bucket of water. And what you do, if you can't be there for quite some time, is you actually hang string down from the soil into the water for each one of them. And since the spaces in the cloth of the string are really small, water will get stuck in those spaces, and the water beneath it will get stuck to the water that's stuck in those spaces, and it will push the water forward. And the water will be able to creep up the string, opposing gravity. And we call this capillary action. And you can keep the soil wet without ever having to continuously water it. Okay? Now, capillarity works best in the smallest spaces. Okay? So how did I always remember this? Well, it's something you might have learned in 6th grade because you did biology back then. There are 3 blood vessels in our body. The largest are the arteries, the medium size are the veins, and guess what the smallest ones are called? Capillaries. Now, the capillaries in our body don't actually use capillary action. A lot of people think they do, but they don't. But the fact that they're the smallest always helped me remember that the smallest material, my wife's laughing at me right now, the smallest material has the greatest capillary action. So let's just, this is a lot easier when the kid's filming, okay? So now we're going to draw the graphing relationship. So what we're going to have here is particle size and capillarity. I'm just going to put a C. Okay, so if the particle size increases, well, capillarity is greatest in the smallest stuff. So that means when the particles are small, capillarity will be high, and when the particles are large, capillarity will be low. So this is an inverse relationship. So as particle size increases, capillarity decreases. Okay, and that's the last major concept of factors that affect how water enters the ground. So just to do a quick review for particle size and how it affects the different things we've learned. Particle size has no effect on porosity. It has a direct effect on permeability. So the larger the particles, the greater the permeability. It has an indirect relationship with retention as well as capillarity. Okay? The next lesson will be about the water cycle and factors that affect two new terms we're going to discuss, infiltration and runoff. All right? I'm going to post a bunch of different videos. One of them involves something called capillary tubes, which normally I would show you. I'll describe them and hopefully you'll understand it if you watch the video. So capillary tubes, so let's say you have your bucket of water again. And they're extremely narrow tubes. And what happens is when you dip it in the water rushes up. And the narrower the tube, the higher it goes. So this tube is wider than that tube, so the water didn't rise as high. Okay? And while I'm on the topic of this, something you definitely learned in science, so let's say you had water in a test tube. Do you read the water level from here or you read it from A or B? You read it from B. And that's a term most kids always remember because it's a fun word to say. You read it from the bottom of the meniscus. So capillary action causes this curvature in the water level. So if the tube was more narrow, there'll be a greater curve. All right? There'll be a greater kind of range in your meniscus. All right? And this is actually caused by what's called surface tension, which is really the underlying principle behind capillarity. Once again, if you have questions, feel free to email me. Have a nice day.